Hi everybody, welcome to our channel EASI. Everything about semiconductor industry or everything that you need to know about semiconductor industry. In today's session, we are going to talk about semiconductor end products. So without any further ado, let's get started. Today, the global semiconductor market is a $1 trillion market that reflects the critical role this industry is playing in modern day technology and digital infrastructure. Semiconductor chip end products span over diverse industries, each with unique requirements and growth trajectories that drives the innovation. Now let's talk about some of the applications. Consumer electronics represents the largest volume segment. Starting from smartphone, laptops to wearables, semiconductor chips power the devices we use daily, driving an unprecedented innovation in this category. Semiconductor is playing a vital role in automotive applications as well. Semiconductor chips are revolutionizing the automotive industry, enabling electric vehicles, advanced driver assistance, and intelligent infotainment. Semiconductors are equally instrumental in telecom and networking, the infrastructure that keeps our world connected. It enables the high-speed data transmission and seamless global communication. 5G base stations to data center infrastructure all depend on high-performance semiconductors. At the same time, semiconductor chips are powering the automation revolution, enabling robots, IoT, and smart factories with unprecedented reliability and durability for demanding industrial environments. That was about the applications. Now let's talk about the end products. The end products refer to the integrated circuits or the ICs used in the electronic devices. That is, the finished chips that power the modern technology. Semiconductor end products can be broadly categorized into two: logic and memory. Logic chips perform computation and control functions, serving as the brain of the electronic system, while on the other hand, memory stores the data and the program instructions, enabling devices to retain and access information. Now let's talk about the logic and memory in details one by one. So the logic chips are the computational engines of modern electronics. The semiconductors perform the processing, decision-making, and control functions that power everything starting from smartphones to the data centers. At the heart of every computing device lie a logic chip that executes the instructions, manage the data flow, and coordinate system operations with precision and speed. Logic chips can be categorized into three: microprocessors, microcontrollers, and the ASICs and FPGAs. Microprocessors or the XPUs are the processing units that execute instructions and perform calculations in computers and servers. Microcontrollers, on the other hand, are the compact integrated circuits designed for embedded applications in automotive, industrial, and consumer devices. On the other hand, ASICs or the application-specific integrated circuits are the solutions for all the customer demands. And the field programmable gate arrays or the FPGAs are mostly for flexible and reconfigurable logic. Now it's turn for memory. Memory semiconductors are essential components that store data and program instructions. These chips enable systems to retain information both temporarily during operations and permanently for long-term storage. Memory products are categorized into either volatile memory like the DRAM and SRAM and the non-volatile ones like the NAND and NOR. DRAMs or the dynamic RAMs are the high-speed volatile memory used for active data processing in computers and servers. It requires constant refresh in order to retain the data. Next comes the SRAM or the static RAM. These are faster volatile memory which are used in CPU caches. It retains data without refreshing. However, it is more expensive per bit compared to DRAM. On the other hand, the non-volatile storage for SSDs, USB drives, and embedded systems come under NAND or NOR. NAND offers high density, while on the other hand, NOR provides faster read speeds. So to compare logic and memory, logic chips perform computation and processing tasks. It controls the operation and data flow and executes instruction and algorithm. Some of the types of logic are CPUs, GPUs, ASICs, FPGAs. Logics are the active processing architecture. On the other hand, memory chips store data and program instructions. They are divided into two types, volatile and non-volatile. Volatile types are DRAM and SRAM, and non-volatile types are NAND and NOR. Memories enable data retention and retrieval, and it is a passive storage architecture. So the key takeaways from today's session are: logic and memory chips are foundational to modern day electronics. They power everything starting from smartphones to data center. Each serve a distinct but complementary function. Logic processes data while memory stores it for immediate or long-term use. So with that, we have come to an end to our today's session. In future session, we are going to cover the continuous innovations in packaging and integrations that is driving efficiency and performance across both the categories. So if you liked today's session, please like, share and subscribe. See you next time. Till then, stay safe and healthy.